So we just have had the introduction for Ayushi also. We just spoke what the blockchain does. I guess the recording is available. You can go through the recording again to understand the initial phase of the meeting, right? The blockchain introduction. So we are from now, we will from here we understand how the peer-to-peer network works, right? So for any blockchain network, we have to understand what has been happening traditionally and what is new that is being introduced by the blockchain technology in itself, right? So usually what used to happen is that we used to, so we will take the example of banks. We will be talking about things such as related to money. So for a bank, any data for the customers, so the people who have been depositing money or lending money or borrowing money from the bank, all these data is actually stored on the banking servers, right? And the banks have the power to manipulate these data, although they do have there have been regulations in order to share these data with the concerned authorities. In the case of banking, it is the RBI. RBI does know about the money which is being saved with the bank, but there's not complete transparency there as well. Now, about the data of the customers with the bank, it is actually centralized, and the bank have complete authority over that data. Nobody knows whether or not they are selling the data to a third party company, as oh, like they do have the power to do so. And we know that in many cases the data of the customer is actually shared for the credit card companies, and they do call us, all of us, on a regular basis, and that breaches the privacy of users of that bank. So there's no transparency because the data is completely like used by the bank, and they can actually make changes on it. Then there's no privacy for the data because they can always use these data to have their own insight. They can analyze the data, they can use it in different form in order to sell their own policies, or they can sell it to different third party companies for them to contact or market their product to the same customers. So there have been some other kind of disadvantages with the traditional banking methods. Let's say the banks are able to decide what sort of interest that they would be paying on the money that they get from their customers. For you can take the example of fixed deposits or the recurring deposits. The percentage of earnings that you make on your deposits is really low, and the bankings are basically able to make a lot of money by making sure that they are getting more money by lending these people to the businesses that they charge a lot of these extra interest money. And then the people who are the people whose money they use for lending these amount, they do not get the complete share of it. So Bitcoin or blockchain technology in itself basically solves this problem. Uh, it removes the middleman. So, when you're depositing the money in your bank, the bank is actually the middle person who is taking care of your money, who has made some rules that they will be changing with their will. And with that rule, you will have to operate, the customers have to operate. Now, what happens in a decentralized network of blockchain, because there's no central authority, because there's no middleman, the network works on a single rule that has been decided initially while a network is created. Now, we are mostly talking about the public blockchain network. We will be getting onto the types of blockchain network later on, because there are certain type of blockchain. We are now talking about the public blockchain. All of that we have gone through and we have discussed about so far is all about the public blockchain. Now, in a public blockchain network, that we'll also take the example of Bitcoin. It has certain rules that were created initially, and that cannot be really changed. And there are nowadays the new networks, and they can actually have changes, but those changes also happens by the people who have the stakes in the network, the maximum stakes in the network. So it basically makes sure that you are not going through the transactions which can be manipulated, the data that can be manipulated, the rules where it can be changed, and also your data is completely private on these network. So let's say there have been a transaction between three people. These three people do not have to share their name, their any of their data on a blockchain network. The only data that will be shared will be their private address. And as I was speaking about the components of the blockchain, I said that we have the consensus mechanism, we have the hashing, we have other components, but the most important component is also the digital signatures. One of the most component, most important component of it. Now, this is not just on public blockchains; it's there in the private blockchain as well. Now, what a digital signature does is it allows an individual to participate in a network with a digital identity. Now, there are ways of having a wallet ID. We will again be talking about this in a more detailed video, since this is an introduction class. But I want all of you to know that there is a private address that you will be holding with yourself, and with that private address, you will always be able to sign in and be a part of a blockchain network. And it makes it transparent for you. The private address is not seen by anyone. There's a public address associated with your private address, which will be available to everyone. And when you make a transaction, the transaction is posted on the blockchain network. And when people, the general public, goes up and looks about the transactions on the websites, they will not be seeing your private address. They will only be seeing your public address, and they will see nothing else about your identity. And this brings what we need for the privacy, because now nobody can take the advantage. Because as we had in the banking industry or any other industry which is just based on the authority which is centralized, that the data that they collect is way more than your name or your date of birth. They have a lot of these different things that they ask you on uh, behest of verifying you as a customer, and then they do share these data with different companies, and then they try to sell their own policies or market their product to you using that data. So it basically protects your identity by using the concept of the public and the private keys. And that is what is special about the blockchain technology, because it protects your identity. Now, again, we will be talking about this distributed storage. We did already speak about it in the banking. For that example, we know that the data is stored on a single server, or there can be multiple servers sometime, but we know that there are very limited source of these data, source of these data, because they are limited databases. And if these databases goes down, that the data is lost. Again, that the bank has the complete authority to change the data whenever they want to. In case of blockchain technology, the data is not stored on a single device. It is stored among the people who has participated in that blockchain network. We call these people miners or the validators. They do take care of your transactions. One of these miners or a validator, or maybe sometimes the group of these miners or validators, are allowed to post the transaction onto the blockchain, and then they earn rewards whenever they post it on the blockchain. So this is the distributed nature. It helps us to make sure that the data is never lost. um, the way they do it is by basically taking a set of transactions, having that put it in a sequence using their timestamp. So let's say there are five different transactions. We know the timestamp, when exactly at what time what transaction is made, and we arrange it in a sequence using the timestamp. Then we hash it. The hash there are different ways of hashing multiple transactions. There's a concept known as Merkle tree, which is very famous in uh, hashing these different sort of transaction. It is famous because it is very efficient. We will be talking about this in our next class. So we hash our transactions which are there in the ledger. We put it on the block, and we then hash the entire block. Now, this is a bit different in different type of blockchain, because every blockchain has its own consensus mechanism. As I said, that we will be talking about consensus mechanism in a bit detail later on. So these hashes will have the address associated. So every block, once it is hashed, it also acts at that, like for that block, it will act as an address of that block, right? And since you have multiple blocks, every block will have an address, and every block will have an address of its previous block as well. And you know that the blocks are in a sequence, because let's say that there's block 1, as you can see in the slide. The block 1 will have its address, the block 2 will have its address, and the block 2 will also have the address of the block 1. Similarly, the block 3 will have the address of block 3, but it will also have the address of the block 2. The block 4 will have the address of block 4, and it will also have the address of block 3. And this is because all of these blocks have also the addresses of its previous block, it is able to connect with these block, and then hence we have the chain of these blocks. And whenever we try to go back and look into these data, which is one of the key features, you can always go back sequentially by going from block 3 to block 2 to block 1, because these blocks are connected only through their previous block hashes or previous block addresses. So it makes it easier to go through the transactions in a sequential manner, right? How all of this is implemented in real using the coding language or the network properties is something that we will be discussing later. I just want to make sure that you guys do have the understanding about how these concept work overall, and later on we can get into how it is being implemented. And is there any questions so far, all four of you? Is it all okay? And
Vipul,
as I said,
question.
yes,
Can you just quickly tell me a little more about what hash is? I mean, that's something you spoke a little earlier, but once again, what is
right,
hash?
right. So basically, a hash is something. It's basically a string of numbers and alphabets, right? It is derived by using some algorithms. Some famous algorithms is SHA 256 and SHA 512. Again, we will be having to go in detail about these algorithms in the later classes. But for now, I want you to understand. Let's say you have certain data. You have five set of data. uh, we can say there are five different transactions, and then we have to make sure that these transactions are not tampered, right? So you're supposed to have some proof, and this proof has to be there for everyone, but the transaction details cannot be available with everyone, right? Because the hashes are available in the public, and you cannot basically share the complete detail about those transactions if those transaction has any other important stuff associated with it. So these different five transactions will actually go through an algorithm. That algorithm will change the details of those five transactions into a long string of numbers and alphabets. Now these long string of numbers and alphabets is something which is called hash. Now why it is important? Because if, let's say, we have five different transactions, there's any change in the transaction, the hash will change, and it is only one way. So let's say you have a hash and you want to get the transaction details from the hash, you cannot get it, right? But once you have the transactions, the details of the transactions, you can actually try to hash with a similar algorithm. Let's say if you're using SHA 256, you can use SHA 256, and you will always get the same hash, right? And it is used as a validation point by the miners, because when they are trying to verify the hashes of the transaction, they try to hash the transactions, and if the previous hash is not matching with the new hash, it means that there have been some changes in the transaction,
Okay,
right?
great. Thank you.
All right.
Julianne has a
Yeah, go ahead. You can always, like, I think they can surely ask the question. I don't mind being interrupted in between as well. Yeah, Jan, tell me.
Um, yeah. So you were talking about hashes and you were talking about how there's strings of letters and numbers, right?
Right.
So, for example, if we typed in hello, a
Mm-hmm.
set of letters and numbers would come, right?
Right.
So what I'm asking is, these are
Mm-hmm.
unique, as in, is hello the same for any person that's having a hash? So for example, if hello was
Mm-hmm.
18256 and another person put that same hello in
Mm-hmm.
another, would it still be 18256 or would it be
Right.
different?
Right. Right. It is actually, now let's say, let's take the example of just hello, right? It is always going to be the
Yeah,
same, right? But in case of blockchain or any place, you will never have just a single word which is being used, right? You will somehow have the identity of the person who is posting it, right? Now let's say you have, when you go into a blockchain network, you will have your own digital identity, right? You will have a private key of yourself, and you identify yourself on the blockchain network with that private address, right? And with that
yeah,
address, you will have some of your own features that you will have on the blockchain, right? You will either be a miner. Now there are some roles decided, few different types of roles decided on a blockchain network as well, right? Now let's say you have a word hello and you try to hash it, you'll always have the similar hello. But now let's say that you have a hello, and along with the hello, we are also sending when exactly that hello is said, at what timestamp. And now, in terms of computer science, timestamp is something that we take as a number in seconds since the year 1970, right? So let's say we have the year 1970, and just after that we count every second, and from 1970, and let's say we this is 16th of August 9:51 and then some seconds, we calculate the complete time in seconds, and that is something we store as a timestamp throughout all the different languages. So on a blockchain as well, we consider that as timestamp. Now, let's say you said hello right now, and you said hello after 5 minutes. It will both these hellos will be going along with their specific timestamp, and timestamp will be different, right? Because the seconds will be changed after 5 minutes. Now, when there are minor changes, and then you send this hello with a timestamp, then the output of the hash will be different, right?
All right. Yeah.
It is just that if you're sharing an information which is exactly the same, it will always give exactly the same hash. If there's even a minor change, the hash will change.